Hello and welcome to the 6th Func Prog Sweden this year. First, I would like to thank all our recurring guests and newcomers to the channel. Welcome to this meetup and to this Func Prog Sweden 6. Over to today's agenda. Ooh, we'll see if we can share it. Let's see. Ooh, up. Yay! Today's agenda. First up, intro by me, then functional Kotlin with Arrow by Karin-Aleksandra Monoid, and then over to Max, and he will do a presentation on how to hold a presentation in functional programming, in the functional programming meetup. Meeta. Then in the end, I'll do a schedule and summary. But first up, I would like to thank our video sponsor, Odabeat. Odabeat is an IT consultancy company based in Stockholm, and they have an office in Stockholm and in Ho Chi Minh in Vietnam, where a lot of people and developers in Odabeat are working with functional programming. If you want to know more about Odabeat, please check them out in social media or on their webpage, odabeat.com. If you want to support the Func Prog Sweden community, and of course you want to, you should join the Meetup community at Meetup or follow us on the YouTube channel. And if you really like the channel, please buy a t-shirt or something else at the merch store at funcprogsweden.myspreadshop.net. This is where you can find these t-shirts and other things. If you have any questions during the presentation, please use the YouTube chat, and I will ask the presenters, read them up, the questions for the presenters in the end of their presentations. So, let's start. Our first presenter, Functional Kotlin with Arrow by Karin-Aleksandra Monoid. Yes, Karin, welcome to Func Prog Sweden, Karin.
Thank you.
You're welcome. And the stage is yours.
All right, thank you. Hey everyone, my name is Karin, and today I'm going to talk about functional Kotlin with Arrow. So, a small disclaimer, I prepared this talk not for very experienced audience in functional programming, but this talk is based on my experience on working in the company with typical enterprise Java developers, and it's more like how to convince people to use Kotlin and more importantly, use Kotlin with functional elements, and especially with one of my favorite libraries, Arrow. A bit about myself. So I'm a senior software engineer working at Circle.ci, but at Circle.ci, we don't use Kotlin. We're doing Clojure and Golem here. But back in the day, I used to be a Kotlin developer and also have background in Scala, also on frontend, so for Scala.js. I'm living in Potsdam in Germany with 2 cats. So maybe you will hear them meow because they want to add their take on functional programming. Don't be mad at them. They're really talkative and friendly. So I'm also a Google developer expert in Kotlin. And you can follow me on Twitter for more articles or announcements. So let's get started. Today on our agenda is what exactly is Arrow? What kind of library is it? NonEmptyList as an example of domain-oriented functional programming, either as another interesting example of handling errors, and also scary part of monad comprehensions. So what is Arrow? Arrow actually is a library that consists of multiple parts. So there's core, FX, optics, and meta. So today, we are going to talk only about Arrow core, which adds more functional programming into Kotlin. So in Kotlin, we have some elements like we can do map, flat map, but this library gives us more opportunities to express ourselves. And for example, let's start with NonEmptyList. So let's imagine we are working in some fintech company and we have some payments that we are sending to our client. So a payment is described as follows. It's not as important, but there are some fields, phone reference amount with some types. Some fields are required, some fields are not required. And the question is, so, well, can we send the JSON that you can see on the slides? So is a list that is empty valid input or not? So the answer is, from the software engineering standpoint, typically it is. So like an empty list of payments is a list of payments, sure, why not? But sometimes it just doesn't make sense. For example, we are guaranteeing that payments are always there. So we can restrict our domain model, for example, using NonEmptyList. So a non-empty list guaranteeing us that if it's created, it should be always full with some elements, or at least not be non-empty as the name says. And for example, we cannot create non-empty list of, but we can create it with some elements. So looks pretty nice. Well, sounds interesting. So is there anything that can help us? Well, before I go to the next part, for non-empty list, it's easy to integrate in your existing projects because, for example, for non-empty list, there are also the integrations written, for example, for serialization library called Jackson. So everything should work out of the box. And I really like that it's like really simple and can be added to any project. So what else? Let's take a look at either another concept that is really popular in functional programming. But before, let's take a step back, like really back to Java. So let's talk about Java exceptions. Well, typically, if we writing our code and we know that something may go wrong, we're writing something like this: if something's wrong, throw new exception. Well, next we are handling it in the signature, stating that this function actually throws some exception, and somewhere else, whenever we call this function, we will handle it in a try-catch block. It's a working approach, so it's like really simple for understanding. You can see what kinds of errors and exceptions you can expect, and the value that you're getting is like a single layer, let's say. So like nothing wrong with this approach. Let's take a look at a more modern Java than you may find in a bank, so like Java 8. Let's use a stream API from Java. Can we write something like this using our test function that throws a checked exception? The answer is like not really, because a stream API doesn't like functions inside it with checked exceptions, and you should either like put try catch right in the middle of your nicely looking stream, which is like may not look in the best way and be not like the best readable code. Or a typical approach for that is wrap your function that throws a checked exception into a function that doesn't throw a checked exception, and then wrap it again, okay, or rather unwrap to see to derive what was wrong, because or what may went wrong, because we don't only want to have a happy path, but also know that something may went wrong and handle it somehow. So this may not look like the most promising code. Can we solve it somehow better with Kotlin, for example? Yes, we can. So no more checked exceptions in Kotlin. So like by default in Scala, Groovy, and everyone else. So how would you write this exact function with stream that we've seen on the previous one of the previous slides with stream API? Well, in Kotlin, it would look quite simple, and yeah, that's it. Is there any problem with this function or with this code? Well, it looks nice, but sometimes we know that something may go wrong and we want to somehow see it right now in place. So are there any mechanisms in Kotlin for that? A typical approach that is used widely in a Kotlin standard library is saying that function will either give you some result or just return null. For example, to string or null, to int or null from string will either successfully transform your number to int or just say, okay, it's null, sorry. There is nothing wrong, again, with this approach, but the only thing that is, well, that sometimes won't work out for some code is you can only say something went wrong. For example, for a string to int or null, one may expect, okay, for unhappy paths, they might be an option that it was not an integer. So for example, long, or this was not a number at all. So like just some random characters, Unicode, whatever, and you only get null, and you cannot really say, okay, this null is for this, and this null is for this. It's not working like that. So yeah, for simple functions, this works, of course, but what are the other options? In Kotlin, there is also a class result that is oriented on chaining and catching the exceptions as errors and whatever. So it's really easy to use it to avoid like Hadouken-like code when you have try catch inside try catch and inside try catch. Well, the only thing that I don't like on this code, okay, there are two things, like it's not like really expressive still, and it's really eager, like run catching will consume everything that may go wrong. So for example, out of memory error or cancellation exception. So like everything, and hide it from you. And I honestly didn't like to figure it out, where is my out of memory. So, but yeah, this may be an option for you if it fits. Well, if it consumes everything, so can we just describe everything that happens? And in some situations, we actually can. So for example, let's say we are investors, and in real life, of course, there are only 3 options that may happen from our investments. So first option is we successfully invested, so success. Second option will be like the moon was full, which is why all our investments like failed. And the third option will be like global financial crisis happened. So like only 3 options, trust me, I have a degree in financial technologies. It always happens like that. And We can describe all of our failures of our our errors in our API, just like that. Not every time, but sometimes. And what's interesting in this exact scenario, you can see that there is only one success, but multiple failures. And it's actually a very popular pattern in functional programming called either. Either is characterized using two types. Typically in Kotlin, Scala, and other languages, there is a mnemonics that says right is right. So the right side type says which value we will have, which type of the value we will have in case of success. And left says, okay, here will be the failure. So in our previous example, either will be just success, and full moon failure and global financial crisis will be some kind of failure. So, and we can use it for describing happy paths, which and failures, which I will describe slightly later. But before that, there is a similar type called validated. It's almost the same as either. When you look at its signature, it's also characterized by like two values, invalid and valid. The only difference is like, how do you use it? So for example, let's validate a user. Whenever we are using either, we're saying, okay, the first check which fails will be our failure. And for validated, we are collecting them all. So for user, test is an invalid phone. So either will be left invalid phone, and validated will say invalid phone and age, and also name. But in real life, if you can, please don't validate names and read an article about falsehoods programmers believe about names, because human names are really different for every culture and every person. And I don't really like when I cannot order a spare Lego block because my name was too long, or cannot order a ticket because my name has a dash. So please never validate the names in real life if you can. So, and there is not a mix, but the third option for validation called IR, which can be left, right, or both. So for names, I can imagine something like the left is a completely invalid name using, I don't know, cat emoji, like right is a standard name, and both maybe this name looks correct, but it's written using Cyrillic characters. So we have to follow up with user on this one, but it's technically correct, and we are fine with that. So, and the most popular option for all those error handling, I would say, is either. And what's interesting with either is a monad. And why is it important for us? So, do you know what a monad is? I'm not sure. So, like, if you don't know, let's say the simplest simplification, let's say, of what is a monad for like typical software engineer is it's a type, an instance of which can be initialized, and it has a function flat map. So for example, this is a typical flat map for iterable in Kotlin. And as you can see, if you used lists before in Kotlin, you actually used monads. And For flat map, the idea is also the same. You're taking the value just as you would from a list and unwrap it. So, and as you can chain iterables, you can also chain iders. And what's interesting, the chaining of iders works as follows. So whenever something went wrong and either is either left, so something, I don't know, in this example, you couldn't retrieve stock info, for example, all the calculations will stop. And as a final result, you will get this either left. But if every result is either right, you're just continuing calculating. So for example, here page info requires historical data, which is in either stock info, also wrapped in either, and user, which is also wrapped in either. Well, this isn't really looking that great. And since everything shares the same context of either, in Kotlin, we can rewrite it using the pattern called monad comprehensions. So as you can see on this slide, instead of writing everywhere a flat map, we are saying, okay, our common context is either, and we are doing everything in either block. And this magical bind function will handle all those transformations between like values and eithers and dropping the calculations when either is left. So in that case, you can use eithers as if there will be like simple values without wrappers around them. So just user stock info, historical data, just like regular values without like visible flat map. So for how do I write a function that uses either? So it's, well, quite simple. You can either explicitly state, okay, let's create either, return either left and either right. Or for more elegant code, you can say, okay, let's just say we have here either block without explicit wrappings to left and right, and everything should be handled itself. But if you're using modern Kotlin, I think Kotlin 1.7 works with that. You can actually use context receiver. And in that case, you don't need to bind anything to either. It will be handled automatically. You can see in context, in the braces, there's effect scope. So effect scope are those transformations like either. And if you call your function in the context which contains either, so where the context can be derived, everything will work just fine. So for example, here, so like here we have a block either, and we are calling our function get from DB. And yeah, we don't need our bind function anymore because context. So what else can you use as a Kotlin developer from Arrow? So you can also see more core entities like option, eval, look into effects for concept of suspend functions. In Arrow, they have a bit different. They are a bit different. So like parse part traverse for like handling them, and in optics to traverse the immutable structures. And yeah, I think that's it for today. So if you have any questions, yeah. I will answer them.
Thank you. Great presentation, Karin. Thank you very much. Thank you. I don't have any questions, but I have one guy saying he will use monads or burritos from now and onwards. So it might come as a t-shirt soon, who knows, or a sticker. Yes, thank you very much for your presentation. Still no more questions, but I have some questions. What was your first functional programming language? How did you get into functional?
So my first functional programming language was actually Haskell, and it was back in the day in the university, and it was like early in the morning on Mondays, and I was like, well, I will never use functional programming languages anymore because it gives me bad memories. But here we are, so I'm using Clojure, Scala, and functional Kotlin. So like, never say never.
Yes. Then you also mentioned before that you trained, you got Java developers to use functional programming. And that,
Yeah.
yes, how was that? How was it possible?
Well, actually, this presentation was used for that, but the most important step was like explaining people that functional programming is not as scary as a lot of articles are presenting it. So, for example, we can say like a monad is just a monoid in a category and the functors, and that's true, but it's not helpful for an average software engineer. And we can say like, okay, like, can you see the list? Yeah, that's a monad, and everyone is okay, sure. That sounds simple. And I found that explaining the stuff in the simple terms really helped for starting it. And yeah, we started with NonEmptyList actually, and either blocks for handling exceptions. And everyone was like, okay, this is like really simple to read. Let's add more. And this is how I got Java devs into Kotlin with functional elements.
Nice. I got a question here in the chat. Can you stack monads on monads in Kotlin or Arrow?
Depends on what you need. Depends on what you mean by stacking. So I think typically if you are using this either block and you're having this effect scope, you should keep it to a single type of monad. So I haven't tried to combine them. So
yeah, the question was like, as you could stack them in Haskell and get different result types or different result, different.
Well, there isn't like a lot of flexibility in Kotlin with types, so like.
Yeah. What are you currently using? What are you working with on every day? Is it Java or some other popular language?
Well, right now I'm popular language. No, I'm using Clojure.
Okay.
It's like not popular at all. And
it is.
another language.
Yep.
And another language that I'm using is actually completely non-functional. It's Golang.
Ooh.
So yeah,
nice.
It's really like contrasting.
Yeah. With that, well, I don't have any further questions. Again, Karin, thank you very much for your presentation.
Yeah, thank you for inviting me today.
Yeah, you're welcome. I know it's very warm where you sit, so like here in the studio.